Good day, my name is Matija Lesković. I'm the third year PhD student at Stellenbosch University, Department of Viticulture and Oenology. Originally, I'm from Croatia, Zagreb, where I also finished my master's degree in Viticulture and Oenology, after which I been working around the world in the wine industry, starting with harvest in Napa Valley, California, then in Chile, in Austria, and in Croatia. Today, I'll be presenting you the collaboration research we did between Stellenbosch University and the Australian Wine Research Institute. And this topic is part of my PhD thesis. The topic is copper the solution to fixing reductive wines? Post-bottling results from a recent study shed some light on the exact effects. So let's start. What are the volatiles? Let's start with a quick introduction. Those can be found in many exotic fruits, such as passion fruit, guava, and grapefruit. These are the volatiles sulfur-derived compounds, and they appear also in different grape varieties as odorless precursors, most importantly in Sauvignon Blanc, Chenin Blanc, for example. And these odorless precursors are then released during the fermentation, meaning that if we chew the berry, we will not sense these aromas, but once the fermentation in wine is happening, we will start to feel this tropical smell, tropical aromas coming out. The most important volatiles in Sauvignon Blanc are 4-MMP, 3-MH, and 3-MHA. 3-MH is the most abundant volatile, and it has the highest ranges in wines and also the highest perception threshold. On the other hand, we have volatile sulfur reductive compounds. Those are very smelly sulfur compounds with very low sensory thresholds, and they are giving the off odors of rotten egg, cabbage, and onion. And generally, they are formed during the fermentation due to the low availability of nitrogen, lack of oxygen, shortage of vitamins B5 and B6. The most common volatile sulfur reductive compounds are H2S, or hydrogen sulfide, and methanethiol. Hydrogen sulfide gives the off odor of rotten egg or boiled egg, and methanethiol is mercaptan, which gives the off odors of putrefaction, cooked cabbage, or cabbage. The solution to the H2S, usually during the winemaking in the final stages before bottling, is addition of copper. Copper is very efficient in reduction of H2S off odors, and it works by binding H2S to non-volatile molecule. However, methanethiol is only as half as efficient in removal with copper compared to the H2S. So even though we add copper to the wine, our cabbage smells, our aromas from methanethiol will be still preserved in wine. There's a lack of research on how does copper influence both positive aromas in wine, for example in volatiles, which are giving these tropical aromas, and negative aromas, which actually we want to remove with addition of copper. Also, there's a lack of research on short and long-term effects of copper finding on stored wines. So our research aims were to investigate these two topics. Our experiment was done on a base wine, which was Chenin Blanc wine from 2019, which was naturally high in volatiles and tropical aromas. We first spudged this wine with nitrogen to remove or to reduce the oxygen, and also we did very reductive bottling of the base wine using nitrogen gas to push wine from tanks into the argon-filled bottles. Those bottles were then capped with the crown caps, so that there's no oxygen permeable into the wine. Furthermore, we prepared our H2S and methanethiol in these anoxic chambers with argon atmosphere. So during the preparation, the oxygen levels were under 1%. So what was our experimental layout? For our experiment, our baseline was Sauvignon Blanc 2019, as I said, a high in tropical aromas or Varietal thiols. And to these wines, we added in different combinations H2S, methanethiol, and copper. So we basically ended up with all the possible combinations between these factors. And there were 8 of them. Those 8 combinations were then stored either in 24-hour, 6 weeks, or 1-year period. And at each of these time points, we did a chemical analysis at the Australian Wine Research Institute, or we did a sensory analysis at Stellenbosch University. Our chemical analysis was done on free H2S, which is this available H2S which is volatile and we can actually smell it, and also bound H2S, which is the one bound to either metals or the wine matrix in wine, and you cannot actually perceive it. As we expected, after 6 weeks, copper reduced free H2S drastically, and that is just supporting the main reason why is copper such a wide used finding agents for H2S. However, our results show that copper creates H2S as well in our base wine or control wine, and that the same H2S is then rebound to copper. That is the good news. That means that although the H2S is created, it is rebound back to copper, so we cannot actually detect it by smelling. With methanethiol, after 6 weeks, we did not detect any difference whether it was copper found or not, meaning that copper is not as efficient finding agent for methanethiol as it is for H2S. Speaking of the Volatile, our free MH, which gives the passion fruit and guava and grapefruit tropical aromas in wine, free MH with addition of copper was drastically reduced in our control wine, meaning that copper added to the control wine did reduce drastically free MH in wine. However, when copper was added to the wine which contained H2S and free MH, which was naturally in it, it seems that reduction of free MH was less apparent. This we can explain due to the copper preference for binding the H2S in wine over the free MH, meaning that if there is a free H2S in the wine, and that is a reason why we would actually add copper to the wine, it will first bind to H2S, and then only the residual copper will possibly bind to the free MH, which we don't actually want. Free MHA, another volatile, was not affected by the copper addition. And moving to our sensory data or the sensory analysis, passion fruit after 24 hours was significantly suppressed in the wines that contain reductive compounds, and that is something that has been already proven before, but we just confirmed it, meaning that wherever H2S was present in very high levels in wine or methanethiol, there was a suppression of fruitiness or tropical fruit, such as passion fruit in the wine. On the other hand, we saw that if to this reductive wine copper was added, our passion fruit went back very fast after 24 hours and was actually in very high levels as the tropical samples. And also, where copper was added to our control wine, which didn't contain any reductive added compounds, it seems there was a very slight increase in the passion fruit attribute or the passion fruit aroma. And that could be due to the copper binding to any residual H2S that was present in control wine, as we saw on the beginning, which was very small, but still it did cause a little bit of effect. This all is in a way changing after 6 weeks, And after 6 weeks, what happened is copper addition decreased the passion fruit aroma in the wine. This is the most apparent in the wines that, such as control wine or base wine. If we added copper to the base wine, there was a slight decrease in the passion fruit aroma. This is also in accordance with our chemical data showing that actually copper does bind to our volatile thiols in wine. If they are added, if the copper is added to our non-reductive wine. Oleic attributes after 24 hours were the highest in the samples containing H2S, which is logical. And we also saw that after 24 hours, there is a drastic reduction in our boiled egg aroma if the copper was added. And if we compare copper-treated reductive H2S sample compared to the control, there is no difference between them, meaning it is really effective in removing this off odor from wine. Also, we have to mention that because we added H2S to our normal fruity base wine, after 6 weeks we noticed that H2S was drastically absorbed also by the wine matrix itself, meaning that all the kinols or similar compounds in wine bound to H2S and reduced it. We can assume that in winemaking situations where your wine really end up highly reductive after your fermentation, that these kinols are in a way saturated by it, which would make a different outcome. On the other hand, even that this wine matrix did absorb H2S, if you compare it to our copper-treated samples, there was still significantly, or like the H2S was higher than our treated samples treated with the copper. And moving to the cabbage aroma, after 24 hours, we saw that the cabbage of odor was the most increased in the samples which contain methanethiol, which is something that we could expect. However, copper did remove our cabbage aroma from the wine, but this removal was only partially happening compared to, for example, our H2S removal with copper. We see that here there is still cabbage of odors which were detected after the removal. After 6 weeks, cabbage of odor was basically the same in both wines containing methanethiol with or without copper treatment, meaning that copper is not actually as efficient in removing the methanethiol from the wine. So, what are the conclusions of this presentation? Copper is effective in reducing drastically H2S off odors within 24 hours. Copper is less effective for reducing reduction of cabbage of odors derived from methanethiol. And excess copper seems to significantly reduce free MH concentrations when H2S is not present in the wine, and hence slightly reduce passion fruit aroma in the wine. This is based on results of only the Sauvignon Blanc white wine. So further research is needed to expand on this concept on the other grape varieties and wines. We can assume that Sauvignon Blanc, which contains more methoxypyrazines than Sauvignon Blanc wine, had also the effect on the perception of the aroma compounds in wine. The final conclusion is, when adding copper, use only the smallest amount necessary to reduce H2S smell in wine to preserve volatile thiols or tropical aroma in wine. So we saw that basically when wine contained H2S, uh, the, and we added copper to it, it preferred binding to the H2S over our volatiles or tropical aroma. However, when there was excess of copper compared to the H2S, like for example in the instance where the copper was added to the wine which didn't contain any H2S, the copper did bind to our volatiles. So the recommendation here would be do the small scale pre-trials when you would basically add to your samples copper in different amounts, and when you smell that, for example, for the H2S is removed in some of the samples, choose the one that you added the smallest amount of copper in, because that one will remove H2S, but according to our results, it will not remove then the tropical aroma from the wine. This is still the ongoing trial, and 1-year wine storage results are coming soon to see what is the further development of these wines. We thank you for your attention, and I would like to thank the WineTech, founder of this research project, Volatile, for supplying us the wine for the research, and a personal thank you to Croatian Scholarship Fund and Mr. Mike Mijeko-Grgić in Napa Valley, which personally support me during my wine research journey. My name is Matija Lesković, and if you have any further inquiries, please contact me on my email address matija@san.ac.za. Have a nice day, and thank you again.